Ladies and gentlemen, the topic of discussion today is the irrigation and rainwater management. As you all know that water is the important and most critical factor in agriculture and crop production. Nothing can grow without water, and therefore the management of this important resource in agriculture and crop production is very important. The crops require water for meeting out certain important biochemical and physiological activities within their body. They require water to meet the transpiration laws, and they require water to build up their body tissues. And as I said, if there is no water, there is no crop production. Now, the requirement of water of these crop plants is normally met from rainwater, and if rainwater is not sufficient to meet out this water requirement, then a farmer goes for artificial application of water to the field, which is known as irrigation. So, if we define irrigation, it is a controlled application of water to crops vis-a-vis to soil through man-made systems to supplement water requirement not satisfied by the rainfall. And irrigation management combines the entire process of application of water right from the source to the user, that is the crop. So, it includes in the process topics like the regulation of water, distribution of water, conveyance of water, application of water, intake of water in the soil, absorption of water by the crops, measurement of water, and so on and so forth. The drainage of excess water in waterlogged soils in proper amount and at the right time is also a very important component of irrigation water management. Now, when we talk of the irrigation water management, there are three important questions which the water manager must know, and the answers to these three questions actually is the backbone of the irrigation water management. The question number one, when to irrigate? When to irrigate means what is the right time of application of water to the crop? Question number two, how much to irrigate? That means how much water has to be applied in each irrigation. And question number three, how to apply this water, that is the method of water application, the method of irrigation, because the method of irrigation is very important in the sense that it decides the irrigation use efficiency. Now, let us discuss these three questions one by one. When to irrigate, that means the timing of irrigation, and that depends on the crop water requirement and the availability of water. As I said that the water is required by the crops for completing certain biochemical and physiological processes in the plant so that they can add up tissue to their body, and soil water has to be in the optimum available range so that the plants do not suffer from the moisture stress. Now, normally the field capacity is considered to be the upper limit of this optimum water available level, and the lower level is the moisture content at which the extraction of rate of water by the crop plants from the soil just equals or start falling short of the rate of consumptive use rate of the water by the crops, and irrigation must be applied before the lower limit of optimum available water range is achieved. The time of irrigation can be decided either taking into consideration the soil factors, some properties of the soil, or some crop characteristics, or some climatic parameters. When we use soil as an index, there are two important properties of the soil which can guide us for the timing of irrigation. One is the soil water content and the other is soil water potential. As regards the soil water content, irrigation has to be applied to the crop when about 50% of the available soil water in the root zone is exhausted. And with respect to soil water potential, the crop must be irrigated when a given soil water potential for a given crop is reached in the root zone. Likewise, there are certain crop characteristics which indicate the timing of irrigation. First is, and very easy to observe by the farmers, is the plant appearance. The irrigation is applied when a change in color of the foliage of the crop is observed, or the farmer observes wilting, drooping, curling or rolling of the leaves, or when the farmer observes that the crop growth is stunted. Likewise, the plant water content or plant water potential, which is very sensitive to moisture stress, can also be used as an index of irrigation scheduling. The most common method which is used by the agronomists is the application of water at the critical crop growth stages. The critical crop growth stages are the physiological stages at which the crop is very critical for the moisture stress. If the crop suffers from water stress at any of these critical growth stages, it experiences a very serious loss in biomass production. And these critical growth stages, they vary from crop to crop. But if you study the critical crop growth stages of different crops, you will find that the flowering stage is the most critical stage of the crop for water stress. Likewise, the indicator plants have also been used for scheduling irrigation. Now, indicator plants are those plants which are very sensitive to moisture stress and they very clearly show the symptoms of moisture stress, and they are grown along with the main crop, a crop which either does not show very clearly the symptoms of water stress, or they show the symptoms of water stress when some amount of damage to the biomass production has already been done. For example, in case of onion crop, the sunflower is used as an indicator plant. The stomatal aperture, which is sensitive to moisture stress, has also been used as an index of for deciding the timing of irrigation. Of late, the farmers have also started using the crop canopy temperature as an index of scheduling irrigation, and the crop canopy temperature is measured with the help of the infrared thermometers. Now, climate parameters can also be used as an index for scheduling irrigation, and it is based on the fact that for optimum biomass production, the crop plants must transpire at potential evapotranspiration, and irrigation must be applied when the actual evapotranspiration starts falling short of the potential evapotranspiration. Similarly, IWCPE ratio, that is irrigation water depth to cumulative pan evaporation ratio, has also been very successfully used to time the irrigation, and the irrigation is applied when a prefixed IW over CPE ratio for a given crop, depending on the climatic conditions of course, is reached. Now, after we have decided the timing of irrigation and the amount of irrigation that has to be applied, that depends of course that how much water is left in the soil profile. The third important thing is how to apply this water to the crop. That means the method of irrigation, and this method of irrigation will depend on the soil characteristics like topography, the soil texture, the infiltration rate of the soil, water holding capacity of the soil, etc., etc., etc. The type of the crops we are growing, whether it is a field crop, is it a fruit crop, is it a orchard, is it a row crop or covering crop, and also it would the method of irrigation would also depend on the quality of irrigation water as well as the availability of irrigation water. So based on these factors, one can decide among different types of irrigation methods, starting from surface irrigation to subsurface irrigation to sprinkler irrigation to drip irrigation. And the efficiency of the irrigation increases in the same direction, that is from surface irrigation to subsurface irrigation to sprinkler irrigation to drip irrigation. The quality of irrigation, as I said, is very important in deciding the frequency of irrigation, the amount of irrigation to be applied, or the method of irrigation that has to be applied, and the quality of irrigation depends on certain chemical parameters like the total dissolved salts, that is the EC, the soluble sodium percentage, the soluble adsorption, the sodium adsorption ratio, the boron content, the pH, and cations like calcium, magnesium, sodium and potassium, and anions like carbonates, bicarbonates, sulfates, nitrates, chlorides, etc. And another important thing is the availability of the water. Now based on the irrigation water availability, there could be three situations. One, the optimum water is available for irrigation, the deficit water conditions prevail, or excess water conditions prevail. Now whatever we have said so far is for the optimum water conditions. Now in case there is a deficit water condition, then we must go, that means the farmers must go for water harvesting, which is also known as rainwater harvesting. These are synonymous terms. And the water harvesting or rainwater harvesting is the process of collection of water, storage and its productive use. And this water comes from the either rainfall directly or from runoff or from the flood water. And the objective of water harvesting is to augment the water resources for irrigation purpose, for human consumption, for livestock consumption, from groundwater recharge point of view, or also from point of view of erosion control. There could be any objective for that. There are different methods of rainwater harvesting, and they can be conveniently grouped into three categories or three systems. The system number one, in which the runoff from the catchment area is collected and either stored in some suitable water reservoirs or directly applied to the agricultural fields. Number two, the second system is that the flood water is diverted to the agricultural fields, and number three, which is known as in-situ water harvesting, the water is harvested right at the spot where it has to be used. Now in this first system, water is either collected in the suitable reservoirs provided with suitable sealants, so that there is no percolation loss, or the percolation loss is minimized so that the water can be stored over a longer period of time, and then it is used for irrigation. In other case, as I said, the water is runoff water is directly diverted to the agricultural fields. In system number two, the flood water is diverted from the main channel or from the natural canals, natural rivers, by constructing dams or barrages, and it is diverted to the fields for irrigation purposes. And in situ water harvesting, the water can be directly stored or harvested in the fields by providing suitable bunds, or water in the terraced lands from the upper terraces diverted to the plots in the lower terraces for irrigation purposes, or along the contours, and or it can be stored temporarily for improving the infiltration rate in the soil. Now the situation number three, where the excess water situation is there, that means there is a water logging, and this water logging normally occurs when there is excessive and very intense rainfall, when the seepage, or there is a seepage from the canals or the water reservoirs, there is over irrigation, or there is a shallow water table, or under situations where the infiltration rate of the soil is very low and the input is very large. So resultantly there is accumulation of water in the profile, and there is a water logging. Mind it, gentlemen, water as such is not toxic to the plants, otherwise no plants would grow in hydroponics. But the excess water conditions, they lead to certain problems like impaired soil aeration, the build up of the toxic elements in the profile, the leaching of the nutrients, restricted root growth and harmful effect on the soil microorganisms. The provision of proper drainage is the answer to waterlogged soils. So, there are three situations: the optimum, the deficit and excess water conditions, and farmers must take important steps or necessary steps so that this water, which is the most critical factor in agriculture, is properly and judiciously used and irrigation efficiency is maximized. Thank you.